Okay, so our goal by the end of this video is to solve real life problems dealing with the normal distribution. But in this case, we're going to be given areas or percentages first, and then from there we have to find, corresponding z-scores and such to solve the problem. So once again, when we're dealing with these types of problems, especially if you're in an AP statistics course where these could be, free response problems, it's important that you follow steps and, show your work concisely, because the reader, needs to be able to follow what you're doing in order to give you the full credit. We don't want to see, students with answers that, are messy or, we can't really tell if, if they just, got the answer by luck or if they understood what they were actually doing and that sort of thing. So follow these 3 steps when you're doing these types of problems, just like the previous problem that we worked on. We're going to always look at and state the distribution and the values of interest that, the ones we want to find. Then we're going to perform calculations, where we do, our adding, subtracting, the math, so to speak. Make sure we show our work, clearly, whether it's, using calculator or hand or both. Still show your work to some extent. And then always make sure you answer the question in the context of the problem. Okay, so let's look at this example. So here we're given, according to this website, at cdc.gov, the heights of 3-year-old females are approximately normally distributed with a mean of 94.5 centimeters and have a standard deviation of 4 centimeters. We're going to determine and interpret all the quartiles of this distribution. So let's recall what the quartiles mean. But the quartiles are essentially the percentiles every, fourth of the way. So a 25 percentile, even the 50th percentile, and the 75th percentile. And we're dealing with a normal distribution. So normal, and with a mean of 94.5. So 94.5, comma, standard deviation of 4. Again, that's our notation we use to, let others know automatically that the mean is 94.5, has a standard deviation of 4, and that it's normal. So let's draw a bell curve to get a, a visual of what exactly we're trying to figure out. So that's our mean, which is then going to be have a value of 94.5. And if we want to figure out the quartiles of this distribution, we want to find the values. Let's call this one X. We'll call this one X1. We want to find this first value where there's 0.25 area to the left. The next value, or the 50 percentile, we already know because that's just the mean. And that means there's, 0.25 from here to here, or 0.5 to the left of that. Our third quartile, we'll call it X2, would be, 75% to the left, or another 0.25 area between there and there. And so essentially, we just want to find X1 and X2. So we'll just fill in this last one, 0.25, this nickel clean. So we know the percentages are the areas. So now we have to work backwards and figure out the corresponding, values in terms of, the heights. So what we want to do is look for the corresponding z-score values with these areas to the left and between them. So let's look at how this would compare to the standard normal curve. So remember, the standard normal curve is still normal distribution, but it has a mean of 0 and a standard deviation of 1. So right in the middle, we have 0. So here, we want to essentially find, we'll call this one Z1, has 0.25 over here. We don't need to worry about this next one because that's just a mean, 0.25 there. And Z2 would have an area of 0.25 there and an area of 0.25 here. So we want to find these Z values, Z1 and Z2, in the standard normal distribution. So what we can do is, let's first just figure out what those Z values are by using our table. So we go to our table A, and we're going to look from the inside out. We're going to look from the area in here to the corresponding Z-score. So remember, these values tell you the area to the left. So we want to look for the value close to the 0.25 first. You won't usually get the exact, but you want to just get as close as possible. And it's in order, so going up, 0.2451. So it looks like this will be the closest one, 0.2514. And that corresponds with a negative 0.67 Z-score. So this first value, Z1, will be negative 0.67. Let me write that a little better. Negative 0.67. Now let's find Z2. So Z2, 0.75 to the left, because 0.25, 0.25, 0.25. So it's going to be a positive Z value. So let's turn to the other side. So look at the inside, the closest value to 0.75. And that would be right here, 0.746. And it corresponds with 0.67 as our Z-score. And again, if you're picking up on this concept pretty quickly and you have it down, then you probably already figured out right away that these are just going to be opposite values because they both are, you know, symmetrical about the center, 0, you know. Now, what we do with these is we transform them into X values in this distribution. So we kind of go backwards from before. So remember, like our Z-score equation would be, you know, X minus our mean over our standard deviation. But in this case, we're gonna have our Z1 and Z2 values. So we would have Z1 would be, let's make that negative 0.67. That's going to correspond to our X1 minus the mean, which is 94.5, over our standard deviation of 4. And then we solve this for X1. And for the other one, we just set 0.67 equal to our X2 value. So we just do equal to X2 minus 94.5 divided by 4. And just solve for X2 in this equation. So algebra, multiply both sides by 4, then add 94.5. So let's do it all in one shot. So negative 0.67 times 4. And then we're going to add that 94.5. So plus 94.5. And we'll get an X1 value of 91.82. Whoops, I'm running out of juice. And same sort of deal here. We do 0.67 times 4, then add 94.5. And we get 97.18. And again, that makes sense because 91.82 is less than 94.5 and 97.18 is more than 94.5. And they're actually the same distance away from 94.5, just in opposite directions. So now we just interpret these. This is, remember, this is a 25th percentile. So then we can say that about 25% of the 3-year-old females are below 91.82 centimeters. Are below 91.82 centimeters. And then we can say, and about 75% of the 3-year-old females are below 97.18 centimeters. All right, that's all there is to it.